For question number 5, in section 3.5 rational functions, we're asked to give equations of any vertical, horizontal, oblique, or oblique asymptotes for the graph of the rational function. Now the way that you find vertical asymptotes, I'm going to use the abbreviation VA for vertical asymptotes, you're going to set the denominator equal to 0. If you set the denominator equal to 0 and solve for x by adding 2 to both sides, you get x equals 2. This is the equation of the vertical asymptote. Okay. Now this also has a horizontal asymptote. Now go back and review those notes I mentioned about finding horizontal asymptotes. What you need to do is look at the degree of the numerator, okay, the degree of the numerator, and compare that to the degree of the denominator. The degree of the numerator is actually 0. 5 is the same thing as 5x to the 0 power. So the degree of the numerator is 0. The degree of the denominator is 1. Simply, the degree is the highest exponent. Since the degree of the numerator is less than the degree of the denominator, we say that this is a kind of a bottom-heavy function. Again, that's not a math term. It's a term that I use to describe these where the degree of the denominator is bigger than the degree of the numerator. We call it bottom-heavy. And bottom-heavy rational functions will always have a horizontal asymptote at y equals 0. Y equals 0 is the equation of the horizontal asymptote. And you can use both of those to come up with an idea of what the graph will look like. If you use a piece of graph paper, you would draw a dotted vertical line at +2 and a dotted horizontal line at 0. So you would have a vertical asymptote like this, you would have a horizontal asymptote like this, and then you would plot a few points to determine the shape of the graph. For example, if you plugged in 0 for x, you would get -5/2. And if you plot enough points, you'll begin to see that this rational function is going to look something like this. You can also check with a graphing calculator to observe any behavior that may look like an asymptote. So to check these vertical and horizontal asymptotes using a graphing calculator, you want to put the original function into the y equals. So I turn the calculator on and press y equals, and this rational function has a 5 in the numerator divided by x minus 2. You want to put the entire denominator in parentheses. Otherwise, you will get a graph that might look right, but it ends up being the wrong and completely the wrong graph. After you enter the equation into y equals, I always start off with a standard zoom number 6. And you see the graph here. You can see it has a vertical break in the graph right there at +2. That's where your vertical asymptote is, at x equals +2. You can also see that the graph flattens out as you go to -infinity, and as you go to +infinity, the graph gets closer to the x-axis. And that's your horizontal asymptote at y equals 0. Let's move on to number 6. Again, we want to give the equations of any vertical, horizontal, or oblique asymptotes for the graph. The way that you find the vertical asymptote is by setting the denominator equal to 0. Set the denominator equal to 0, and we get 2x plus 5 equals 0. And we're going to solve this for x. We do that by subtracting 5 from both sides. We get 2x equals -5. So x is equal to -5/2. That's our equation of the vertical asymptote. You can check your answer for that. Now the way that we find the horizontal asymptote, we have to look at the degree of the numerator and the degree of the denominator. The horizontal asymptote, I'll abbreviate that with HA. We look at the degree of the numerator and compare that to the degree of the denominator. Now the original equation, the degree is the highest exponent. The numerator was 6 minus 4x. That's the degree of 1. The largest exponent is 1. Even though you don't see it, the largest exponent is 1. And in the denominator, the degree is 1. 2x to the first plus 5. So the greatest exponent is 1. Those are the same. We call this a balanced function. And the way that you find the equation for the balanced functions is to look at the leading coefficients. The leading coefficient, the equation of the horizontal asymptote is equal to a fraction, where it's the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay, that's my abbreviations. And then finally, what that is going to look like, the leading coefficient for the numerator, since that is a negative 6 minus 4x, that leading coefficient is negative 4. It's the, you may think it's 6, but it's actually negative 4. It's the highest exponent for x, the coefficient for that. And then the denominator is 2x plus 5, so the leading coefficient is 2. So this is going to simplify to y equals negative 2 as the equation of your horizontal asymptote. Now the equation for an oblique asymptote. Oblique asymptotes only occur when the degree of the numerator is exactly 1 more than the degree of the denominator. So this one does not have an oblique asymptote. In fact, if it has a horizontal, then there's no way that it could have an oblique asymptote.